So in the previous video, we took a look at how we can rewrite before we actually integrate a function. And so now in today's video, we're going to go ahead and look at how we can actually start integrating functions outside of just simple polynomials or, x raised to a certain power. Now we can integrate more functions. So here we have the integral, or in this video, we're going to cover the integral of e to the x and the integral of 1 over x. And so first of all, I've written out the derivative of e to the x over here. We know that the derivative with respect to x of e to the x is just going to be equal to e to the x. And this holds for any order of derivatives, right? Which is a very, very nice property that's going to prove to be very useful later on in calculus. And so what does that tell us about the integral of e to the x? Well, if we applied the integral operator to both sides of this, if we wanted to take the integral of both sides with respect to x, right, dx, then we would just end up with the integral of e to the x dx is just e to the x plus c, right? And this is going to hold true because if you take the derivative of the integral of e to the x, you just end up with e to the x. And then on this side over here, we get the derivative with respect to x of e to the x plus c. This plus c will disappear, and we just get e to the x as the derivative, because we know that the derivative of e to the x is just e to the x. And so that's a very, very nice property. Whenever we have the integral of e to the x dx, that's always just going to be, or the indefinite integral is always just going to be e to the x plus c. Now, what about 1 over x? Well, we know that the derivative with respect to x of the natural log of x is just going to be 1 over x, right? And if you remember when we were talking about the reverse power rule, we noted that if we wanted to take the reverse power rule, or the integral of x to the n, then the reverse power rule would tell us that this would be x to the n plus 1 over n plus 1, which made sense intuitively. And then we said that n can't be equal to negative 1, right? N is not equal to negative 1 over here, but it can be any other number. And so the reason why n can't be equal to negative 1 is because suppose that n is equal to negative 1. We have x to the negative 1 dx. Well, then that's just going to be the integral of 1 over x dx. And if we were to use this reverse power rule over here, then n being equal to negative 1 would make this whole thing collapse. We'd get x to the 0 over 0, and that just becomes a mess. And so the reason why so for that reason, we have to look back to the derivative of the natural log of x to determine the fact that the integral of x to the negative 1, or of 1 over x dx, is going to be the natural log of the absolute value of x plus c. And the reason why we include the absolute value of x is just to kind of match the domain of 1 over x to the domain of the natural log of x. We know that the natural log, or the domain of 1 over x to its integral, because we know that the natural log has to be any number greater than 0. 1 over x can be any real number as long as it's not equal to 0, so we include that absolute value to kind of match the domain of 1 over x. And so those are two very important, very basic functions that we need to know how to integrate. And so let's do a couple of very quick examples over here. Here we have the integral of 4e to the x. We can take the constant out, or we can keep it in if we would like, and we would just end up with 4e to the x plus c, right? Because, we can, again, if we wanted to take the constant out, we could just write that as 4 times the integral of e to the x dx. And we previously established that the integral of of e to the x is just going to be e to the x. So we get 4e to the x, and then we can't forget the plus c. So that would be our final answer right over there. Next up, this is a definite integral now from 0 to the natural log of 4 of negative 1/2 e to the x dx. And so let's go ahead and actually do that. We can write this as, again, we can take the constant out, so that's just going to be negative 1/2. E to the x will stay the same, and we're evaluating that from the natural log of 4 to 0. So that's going to be negative 1/2 times e to the natural log of 4, and then we're going to subtract from that negative 1/2 times e to the 0. E to the 0 is just 1. E to the natural log of 4 is just 4, so we end up with negative 4 over 2, which is just negative 2, minus negative 1/2, so that's just going to be plus 1/2. And so that's going to be what? Negative 4 over 2 plus 1 over 2, which is going to be negative 3 over 2. And that would be our final answer. So as you can see, it's very easy to integrate e to the x, whether it be a negative or a definite integral or an indefinite integral, and regardless of what the scalar is in our integral. With respect to the function 1 over x, let's say we're taking the indefinite integral of 7 over x dx. I don't know why that just acted up over there. So 7 over x dx, the indefinite integral. Well, we can take the 7 out, and then we end up with 7 times the integral of 1 over x dx. And we have to remember that 1 over x is the derivative of the natural log of x. But again, we want to match the domain, so we get 7 times the natural log of the absolute value of x. So that's kind of an intuitive way to think about why we do include the absolute value, is just to match the domain of 1 over x to its integral. And then finally, we have a definite integral from 1 to e to the 7th of negative 3 over x dx. Again, we can take the negative 3 out, and we'll just get the natural log of the absolute value of x. And we're going to evaluate that from e to the 7th to 1. So that's going to be negative 3 times the natural log of e to the 7th. If we can kind of remove the absolute value here because e to the 7th is a positive number, and then we're going to subtract negative 3 times the natural log of, again, we can remove the absolute value because 1 is positive. Natural log of 1 is just 0, so this entire term goes to 0, and we just end up with negative 3 times the natural log of e to the 7th, that's just 7, so negative 3 times 7, which is negative 21. So I hope this kind of makes sense, and I hope that I didn't really go too fast here. But essentially, it's just crucial to remember that the integral of e to the x, or the indefinite integral of e to the x, is just e to the x plus c, and that the indefinite integral of 1 over x dx is just the natural log of the absolute value of x plus c. And it's crucial to remember that absolute value because we do need to match the domains, as I have mentioned previously. So I hope this helps.